Hey guys, this is 3-5. This is your last section before the next quiz. Hope you're having a good evening, night, morning, afternoon, midday, whenever you're watching the video. For this lesson, this is parallel lines and triangles. There's 2 theorems, 1 postulate, and 2 definitions that you need to know. The postulate that you need to know is called the parallel postulate, and it says through a point not on a line, there is one and only one line parallel to the given line. So in that picture, there is exactly one line through P parallel to L. The bottom line L is the one that you're given, and then if you had a point P, there's only one line that you can draw through that point that is parallel to line L. The 2 theorems that you need to know are the triangle angle sum theorem and the triangle exterior angle theorem. The triangle angle sum theorem, we'll do a little bit of practice in class, but that one says that the sum of the measures of the angles of a triangle is 180. So if you add angle A to B to C, then they're all going to add up to 180 degrees. And since addition is commutative, it doesn't matter how you add the 3 angles, just as long as you add them, you should get the correct answer. They should all add up to 180. The last theorem is the triangle exterior angle theorem. And this one is going to require you to know the definitions that are listed right here. These guys are the two vocabulary terms are exterior angles and remote interior angles. The exterior angles are the angles that are formed by a side and an extension of the adjacent side, so angles 1 in all of these pictures. For each exterior angle of a triangle, the 2 non-adjacent interior angles are called the remote interiors. So that's all of the angles 2 and 3 in these pictures. In each triangle below, you'll see that they're already marked, and I circled them for you. The triangle exterior angle sum theorem the triangle exterior angle theorem says that the measure of the exterior angle, so angle 1, is equal to the sum of the 2 interior angles. So if we add angle 2 to angle 3, we will get the measure of angle 1. Okay, here's problem 1. What are the values of x and y? On this picture, first, let's just take a look at the information that we have. We know that angle A is 59. We know that angle B has 2 measures, 43 and 49, just depending on which triangle you're looking at. We know that angle C is z degrees. And then we know that angle D has 2 different angles. One is x and one is y. There are 3 triangles in this picture. There is the left triangle ABD, the right triangle BDC, and then the big triangle ABC. Out of the 2 between x and y, there's one that's going to be easier to find than the other. And if you look at this, you'll see that x is actually the easier one because you know angle A and angle B. And we know that the theorem, the triangle angle sum theorem, says that all 3 angles add up to 180 degrees. So if we add 59 to 43, we can then subtract that from 180, and that's going to give us angle x. So again, we know that 59 plus 43 plus x is equal to 180 degrees. Add 59 and 43 together, and that gives you 102. Oopsies. Let's try that again. And that's equal to 102. And then subtract the 102, and you end up getting that x is equal to 78 degrees. From that, you can find angle y. We know that angle x and angle y form a linear pair. So that is one way to do this. Or you can use the exterior angle sum theorem that says that angle y is equal to the sum of these 2 interior angles. So 43 plus 59 is equal to angle y, which means that angle y is 102 degrees. Okay, our next question is going to be using the triangle exterior angle theorem. So now we're going to look at this particular one where we're trying to find the measure of angle 1. Remember that the exterior angle is equal to the sum of the 2 interior angles. Remember that the 2 interior angles are created by the 2 sides and the non-adjacent side from the angle 1. If I add 80 plus 18, I get 98 degrees. and 98 degrees is the measure of angle 1. So pretty simple, nothing too complicated. What's going to be important is that you remember the definitions and remember that the two interior angles are the ones that are not anywhere near the angle that's on the exterior. So let's try another one, and this time we are going to find the measure of angle 2, but angle 2 is now inside. It's one of the interior angles. So if you want to pause the video, you can. If you want to just continue, that's fine. We know that 124 is the exterior angle, and we know that it is the sum of the two interior angles. I'm going to call angle 2x just because I prefer that. My next step is to subtract 59 from both sides, and so once I do that, I end up getting my answer, which is 65, so the measure of angle 2 is 65 degrees. Okay, example 3. When a radar tracks an object, the reflection of signals off the ground can result in clutter. Clutter causes the receiver to confuse the real object with its reflection, called a ghost. At the right, there is a radar receiver at A, an airplane at B, and the airplane's ghost at D. What is the value of X? So there's our airplane, there is our radar, and there is our ghost. So kind of ponder on this question. How can you apply the skills that we just used from the previous question to help yourself out here? Remember that that's the one where we use the triangle exterior angle theorem. So if you want to, you can pause for a second and see if you can figure out how we can use that here. So if you notice, there is a triangle here, and I'm going to color it in and then I'll erase it. There's a triangle here, and that triangle has, there's two interior angles that were given, and that's angle A and B, and then we have this exterior angle here. The triangle, or the exterior angles theorem says that if you have two interior angles that are on the non-adjacent side to the exterior angle, then you know that the sum of the two interior angles is equal to the exterior angle. So what we can do here is we can set up our equation. So I'll go ahead and actually set it up from the very, very beginning. The measure of angle A plus the measure of angle B is equal to the measure of angle BCD. Notice how for angle A and B, I was able to write it down as just angle A and angle B, but for the exterior angle, I had to be more specific and say angle BCD. That's important because if you said angle C, I don't know if you're talking about the one inside of the triangle or if you're talking about the one on the outside. Is it the interior or the exterior? Be more specific so that way it can help you also in the future. The measure of angle A we don't know, so we were given that that's x. The measure of angle B was 30. And then the measure of angle BCD was 80. So we can solve for x by subtracting the 30, and you end up getting 50. So the answer to this question was B. Can you find angle A, though, without using this method that I just used there? Is it possible to do this without using the exterior angle theorem? Ponder on that question a little bit, and be ready when you come back to class tomorrow to answer that question, and we'll discuss that a little bit further. That's all I have for you guys. If you want to look through the Pearson site to kind of get some extra stuff, or if you want to just look at some more example problems or whatever, you're more than welcome to do that. If you need to come in the morning, I'll be here. I will not be available after 8 o'clock. I have a training I have to go to from 8 to 11, so I won't be there second or third period on Thursday, but I will be there at lunch, and then I will be there for the rest of the day in the afternoon and after school. I will still get there about 7:35 though, so I'll be available about 10-15 minutes if you need to come see me. You guys have a good evening, and I will see you guys later.